Okay, hi and good morning from Firefly in our new lab based in Clooney, County Sligo, Ireland. And what we want to share today is a concise, structured approach to how we think you should approach your prescription variables with regard to custom-made foot orthoses, and specifically around 3D print design characteristics. I've created a pretty concise 5-page document which initially was to be used for our staff in terms of technical support to give them a structured approach to how we should be advising podiatrists to approach their prescriptions. So point number one, what we're talking about is that footwear itself determines the custom-made foot orthotic design. So really, if you can think about when your patients arrive at your clinic, whether that's in an NHS facility, a HSE clinic, or in a private clinic, you've got to be thinking about what type of footwear they're wearing. The way I would tend to describe it is think about prescription glasses, and the lens of your prescription glasses are really the custom-made foot orthoses, and the lens is then designed to fit a specific frame. The frame in this case happens to be the type of footwear. So if we simplify it and we think about 3 footwear categories, we think about daily casual shoes, we think about sports shoes, and we think about dress shoes. So those 3 categories then correspond to designs. So in terms of Firefly, we would have a standard functional design, and this would be related to the daily casual shoe. We have a standard sport design, and that would be related to the sports shoes. The difference there is that the standard sport design would have a deeper heel cup, and it also gives you the ability to increase the width of the shell, thereby creating a greater reaction between the shell and the foot itself. The dress shoes obviously create a dress specific design. They tend to be a lower heel cup and much narrower. So each category has unique design parameters. So let's give you an example. The dress shoe would have lower heel cups, narrow midfoot hourglass grind. However, it's got limited space for additional control features. You can't have a wide grind, you can't have a medial flange. That doesn't really work. So what you're really thinking about is what type of footwear is the patient wearing? We have the benefit of being in private practice, so quite often we're recommending multiple pairs of devices, usually at least 2. We tend to think of something like a low profile sport for running shoes, rugby boots, soccer boots, that type of sporting footwear, and then combining that with a dress design so the person can use the devices in more slimline footwear. So again, key principle is think about the footwear. That's the frame of the glasses into which you're going to put the lens, into which you're going to put the custom-made foot orthotic devices. Number 2, we talked about, think about the foot posture index, think about your diagnosis. You're really trying to think about the design in terms of offloading characteristics. So is it a pes plano valgus foot type that has resulted in an overloading of a structure, or is it a pes cavus foot type that has resulted in the overloading of a structure? I do like to think about the first principle of orthopedics that talks about putting everything in its first place. In terms of our lab, what that really means is all scans will be corrected to calcaneal vertical unless otherwise specified. So what does that really mean? We're going to position the ankle and foot at 90 degrees. We're going to expect to try and get that subtalar joint in a neutral position. We're also wanting to seek a locked mid-tarsal joint by loading the lateral column, and we would like to have all metatarsal heads corrected to a perpendicular alignment to the corrected calcaneus position. So that's a kind of a corrected baseline, and it serves as a foundation for the manufacture of all custom-made foot orthoses. So think about it again, put everything in its proper place. The next thing we talked about was standardized base designs. So as a starting point, 80% of prescriptions can be effectively covered by combining the corrected anatomy with the footwear specific design. that we've sort of highlighted initially here. So for us, one of the things that I would do quite often is I quite often like a metatarsal pad in the shell. I like the new first ray accommodation that can be designed within the software. This allows a plantar flexion of the first ray. It has a small first MTP joint cutout, but it doesn't rock. The device is stable on the ground. I also like a thing called a ghost post. The ghost post is again new. That can be designed within the software, and it creates a stable platform on the plantar surface of the heel of the orthotic. We use that when it's an intrinsic rear foot posting and there is some form of rotation. You don't need to use the ghost post if it's simply posted to calcaneal vertical, where you're not rotating the heel into either varus, which is the most common, or valgus. So the core design is then matched to one of the three footwear profiles. So functional, daily, casual. The sport is the standard sport with your sports shoes, and then the dress for the men's or women's. So again, 80% of prescriptions, if you simply put them to calcaneal vertical and you corrected the forefoot to the rear foot position, bringing all the med heads on the same plane, 80% of your patients are going to benefit from that offloading design. Of course, then it moves on to more advanced designs, and this is for the more complex pathologies that you're going to see, probably 20% of your patients. This is really looking at the foot posture index, again linked to a diagnosis. So for instance, an adult acquired flat foot, and conversely on the other end of the scale, something like an advanced pes cavus. So the foot posture index and the specific design options now allow you to think about in-shell designs. What can we design within the shell using software and then 3D print it to create offloading characteristics that traditionally we couldn't do? So for instance, let's say you're looking at the collapsing pes planovalgus foot type or something like an adult acquired flat foot, and we want to promote a device that increases supination moments of force. So we can do things like a medial flange, we can increase the medial arch fill, we can do a medial heel skive, we can do inverted cast corrections, we can do a deep heel cup, we can do a plantar fifth ray grind. That basically increases the height of the lateral arch and therefore locks the mid-tarsal joint and loads that lateral column. Of course, you can do a medial rear foot wedge, you can do a cuboid notch for perineal offloading, and then you can increase the shell stiffness by adding things like a medial stiffener bar. This keeps the bulk of the device low, but makes it very stiff for maybe certain sporting applications or for patients that are significantly overweight or obese. And then conversely, you've got to think of the pes cavus, the high arch foot. So you want to design a product that creates pronation moments of force. So how do we do that? Okay, well, we can do lateral flanges, sometimes known as lateral wraps. We can do lateral heel skives. Again, first ray cutouts or accommodations, forefoot valgus posting. We can lower the medial side of the device. We can do plantar fascial grooves. We can do wide grind to increase the base of support. All of these are in-shell design characteristics that, as we kind of evolve the software, that as a podiatric profession we need to learn. We don't need to add soft materials that wear out and are all, of course, made from petroleum-based materials. So again, just to summarize it, start with the footwear. It defines the initial orthotic design framework. Use corrected anatomical volumetric scans. So position the foot to calcaneal vertical. Get all the med heads on the same plane. That's technically correcting any forefoot supination or supinatus. And then apply our Firefly design features, which covers most of the needs of patients, and then customize those designs based on the foot posture or indeed the more significant pathologies. So that's a really simple approach that initially I've shared with our technical support team to give them an understanding of the principles behind podiatric prescription design. But it's a framework that maybe you as a podiatrist can take and start to increase your knowledge and hopefully improve your patient outcomes. There we go. Thank you.